You're not on page 12. You're on page 11. Okay. Those of you who worked on the practice quiz, the gift that I gave you, did you notice in one of the questions it said do not use mapping notation? And some of you were like, what is this? And I'm like, right now you don't know, but Tuesday you will find out. So today I'm going to teach you mapping notation. And mapping notation is a way of transforming functions where you don't have to think. Okay? It's useful, but it doesn't require you to visualize it. It doesn't require you to do functions aerobics in your head. Okay? But what you did just now is actually pretty much determining a formula for how to know how to transform a point. So if I were to give you, like, remember we had a negative x, was it plus 4? I forget. 3y minus 7. You don't have to write this down. And if I were to now say, well, I have a new point. My new point is 1, 2. Could I use this formula to transform it? Yeah. So let's see what that would look like. If I started with an x equals 1 and I did this formula, where would that transform the function? Minus x plus 4. What would that be? Right, minus 1 plus 4, well, that's positive 3. Okay, and if y is 2, 3 times 2 minus 7 is what? Minus 1. So do you see how you didn't have to really think? You just had to take a number and plug it into a formula? And so people are really going to like it. This is what mapping notation is. It's coming up with a formula that allows you to transform a function. And it's good to have. But notice I didn't use my brain here really. And so on the quiz, what I'm teaching you today, you're not allowed to use it. You can use it as a check. I'm not going to, you can do it on a scrap piece of paper, but if you just use mapping notation, you do not get full points. Got it? So I'm just going to write here, not on quiz. Just so you know, you don't have to learn this for the quiz. Okay. So let's take what you just figured out and put it into a nice little table, a summary table. So when we have, this is a table of transformations. So when we have a vertical translation, right, C, that means we're going up or down. How does that appear in the function? Well, in function notation, it would be f of x plus c. Okay. And when we transform the point, if I just want to make a formula, I take y plus c. And remember how I said that each transformation just affects one point, like one coordinate? Well, this one affects the y. Okay, then we have a horizontal translation, right? That's going sideways. And this one, the D goes inside the bracket. I don't want that. Right, so if I'm writing it in function notation, that number goes inside the bracket together with the x. But if I am just using it as a formula, what did I do? Is it x minus d or x plus d? Plus d, beautiful. Remember, because the d is like opposite of what you see. Okay, then I have a vertical stretch. Is the vertical stretch affecting the y or the x? Vertical stretch. What's changing? The y. Good. So I'm going to put the y here for now. Okay, so the vertical stretch goes in front, right? When we have function notation, it goes in front of the function notation. And when my vertical stretch was 3, what did I do to the y? I multiplied it by 3. So that means It's A times Y. Okay, so we're just coming up with a formula for all these transformations. But then when we have a reflection in the x-axis, so think of the x-axis as the monkey bar. Is that a vertical reflection or a horizontal? If the x-axis is the monkey bar, it's vertical, right? So what's changing, the x's or the y's? Okay, so I'm back to, I still have the y's changing. So I'm just going to put a y here. Okay, and if it's just a reflection, no stretch, that means we multiply the function by a negative. Yeah. So if it's, so think of, okay, so think of the x-axis as the monkey bar, okay? And if you have, let's just say 2 points, okay? And I'm going to reflect them. Did they move to the side? So if they move to the side, that's changing the x. But if you're just moving them up or down, that means the y is changing. Yeah, that one can be kind of, okay. Horizontal stretch K. Is that changing the x or the y? X. Oh, I didn't finish here. Sorry, I was supposed to put a negative in front of the y. Now the horizontal stretch K is a funny one, right? It goes inside the bracket. So in function notation, it looks like this. But then careful, because when we write it as a formula, do you remember what I have to do? What do I have to do to the K? No. No. 1 over X, 1 over K, right? So I'm going to do, it's kind of small. It's going to be X over K. Or you can write it as 1 over Kx. But basically, whatever your K is, you write the reciprocal of it. Okay, so those X's are really causing us havoc. X's are always the opposite of what they appear to be. And then when I have a reflection in the y-axis, am I changing the X or the Y? Okay, so watch here. I've got a point here. It's the Y is the monkey bar. Is it getting low, higher, higher or shorter? No, it's not going up or down. It's just changing the X coordinate. Luke, do you see that? Okay. So what that means is we've got F, and because it's the X that is changing, you put a negative in front of the X. And you don't have to divide X by a negative, because what is X divided by -1 is just negative X, right? Okay, now all these beautiful pieces go together in a formula. So this is what we call function notation of all the transformations. But what we're gonna do is we're gonna write out the mapping notation. So the mapping notation looks as such. So I've got X, and I'm just gonna notice I'm using colors here. I've got X over K plus D. Y CY or Y times C plus, no, take that back, Y times A. Or I guess we write AY, I don't know, plus C. This here, folks, is what we call mapping notation. Okay, this I do not give you on a quiz, But this is something that you want to not just memorize, but like understand how you get it. Okay, it's a wonderful tool. And really, I usually try to give the quiz, like this first quiz, before I even teach mapping notation. But you're lucky in two ways. One, I gave you a practice quiz that's similar to the quiz. Two, I'm giving you mapping notation. And so you can use this on a quiz just to check. Okay, so let's put a big box around this. Okay, and I'm just going to write down that this is called mapping notation. This is how we come up with an equation for the transformations. Now, notice I didn't put any negatives in there. Where do the negatives fit into the mapping notation? Which letters? K and A, right? So if there is a reflection in the y-axis, you're going to put a negative in the K, okay? All right, so let's practice. The function f of x is given, but where is it? We don't know. Doesn't matter. We don't know what it looks like, and that's okay. Describe how the graphs of the following functions can be obtained from the graph of y equals f of x. Then write the transformation using mapping notation. So in question A, what is happening? What do we call this 5? Don't tell me, tell the person next to you. What is it called? Is it a horizontal stretch? Is it a vertical translation? Is it... Okay, pause. Make a point right now. Make a point with your fist, Sebastian. Make a point. Make a point. And do the +5. Good. So it's a vertical translation. So if I were to write out the mapping notation of this function, the x don't change, the x values. It's only the y values that change. And I just write y +5. And so now if I'm like, oh, if there's a 0.11, what's it going to be when it's transformed? Well, you plug it into this equation. So let's actually do that. Let's practice transforming points. So if I give you a point, 1, 1, and see this arrow? This arrow indicates transformed. So what will the transformed point be? Write it down here. Okay, use function notation. So if x is 1, what do I do to the x? Nothing. If y is 1, what do I do to the y? +5. So what's my new y? Okay. So I didn't even have to think, oh, vertical translation, move the y 5 up. Okay, that's what our formula did for us. Okay, let's try question C. Okay, so as you get this, there's two things you can do. It might be good because there's so much happening. You might want to write out the AKDC. Just to avoid making silly mistakes, let's write out what is AKDC. Yeah.
For the mapping notation,
Yes.
wouldn't it be negative except +2? Or
No, because this is it, Mustafa. The negative is part of the formula. So, right, so if you have x minus 3, x minus is part of the formula, so the 3 is positive. Yeah, you're welcome. Okay, k is 1, d is -4, c is -3. Okay, so what is the mapping notation? Let's just plug in these numbers into this formula. Okay, so we've got x, the over k, we're not going to write x over 1, right? X minus 4. Okay. Minus y, or negative y, minus 3, close bracket. Don't copy me. Really try to do this on your own. And if you are copying, say, hey, Miss Lai, where'd you do that? Do you have your booklet? Just take a piece of paper and write it down. Or like, if you can sit and listen, do that. But I have a feeling you're kind of passing out. Just leave that. Yeah, take that. That's just even like you can copy it later, but just so your mind is engaged. Pencil? Is that what you're asking for? I don't know. These are all broken. Does this work? This is a room full of utensils that don't work. This looks like it works. You're welcome. Yes. How did we get negative what? Okay. Tell me. Try to figure it out. Yeah, and the negative that is in front of the F, that is your A. Right? So anything that comes in front of that function note is your A. Yes? Sure. I will give you one that everything is negative in a second. All right. So let's say my starting point is negative 2, 3. Okay. Transform this point based on this function transformation. Wow, a lot of phones out. What's happening? Is there like a solar eclipse happening or something? Okay, put it away. Just like anytime the phone is out, just feel free to, yeah. I had to say that silently because I'm like, this is being recorded. All right. Okay, go ahead, folks. Negative 2, 3, transform it. Okay, візьми мінус 2 і 3, постав тут у формулу. So if you don't know what to do, you're substituting the x and the y into this formula and seeing what comes out.
This Monday off, like next Monday.
I've already taken time to talk about all this. Okay, that was the time to ask me. Yeah. Do you agree? Is it -6, -6, or -6, -6? Okay, and then Luke was asking for, or was it Kajik? Okay, let's do another one. And the point you are transforming, I'll make it easy. So first write function notation, or first write the mapping notation. And then you're going to transform the point 16, -9. ask me questions, really try to do this on your own. Put that phone away. Or is that a calculator? No, put it away. I really see you're very distracted by that phone. It's doing you no good. Please put it away. Okay, and get a real calculator if you need one. Okay, so you're either writing or you're asking me a question. Yes?
Where's the 16 and 9 from?
I made that up. So I said, this is a point. Okay, can you transform it? This is the original point. Yeah, maybe I should write original point. Original point on the original function. And then you're going to find out the coordinates of the transformed. And there was a question in the back. Liam, do you have a question?
Not anymore. I'll just.
Okay.
It's like
Yes.
when we're changing k
Yes.
to 3/4, does the minus stay?
Yes, because it is a reciprocal, not a negative reciprocal. So let's say this. If your k is minus 4/3, I'm going to just assign the negative to one of them. Okay, I'll just put it in the numerator. Well, the reciprocal, 1/k, is just 3/-4. So the negative doesn't go away.
Oh, so we always have negative when we're like.
That's right.
Okay.
You're just flipping it. That's right. So it doesn't matter if the negative is in the numerator or denominator. Because remember, you have to do in the mapping notation, we have that it's x over k. So the over k is telling us that it's 1/k. So you have to take your k and flip it. You either write 1/, but if it's a fraction, you have to write the reciprocal of the fraction. Is it 1/k? No. 1/k is the same thing as 3/-4. Like, this is a reciprocal. So whatever you see in the function notation, right? If I have -4/3 in the notation, I'm like, you're not going to trick me. Because you're doing something to the x, I know that you're trying to trick me, and I need to flip you. Okay? So when you're applying it to the x, you're actually multiplying x by -3/4. And I purposely gave you 16, which is a multiple of 4, to make it easier for you.
Thank you.
You're welcome. Okay, and then I've got, but then for the a, I don't change it, right? It's -1/3y minus 2. Okay, so what is the new point? Okay, so I'm going to get 16. So it's going to be -12. You tell me if I'm making a mistake or not. It's going to be 3 minus 2. Is it -7/1?
Yeah.
Great. So that's sort of, that is almost as hard as it gets. Do you want to see what would make it harder?
Yeah.
Okay. What would make it harder is if I didn't factor it, right? So if what's in the bracket would ask you to factor, and which question in the homework, which question from A, B, C, D makes you factor, right? So you get a chance to practice that. All right, but I want to move on and do one of each of these. So let's look at question 2. Actually, do I think you can do that on your own? Yes. Yes. Yeah, you can do all of this, folks. Number 3 and 4, we've been actually doing it. Now, this is the weird thing, because usually Mr. Maccini, who created these wonderful booklets, he always provides the answers. And because I think this lesson is not in the textbook, right? So he created the questions, and the answers are on the back, like are on the next page. So it looks like it's like, oh, it's the exact same thing. but that's just the solutions to the homework. So please, like, don't look at them until you really need them or until you're done. Does this make sense? Is there something I need to do in the next 15 minutes, or do you have time to work? Is there anything I needed to answer? Okay, there is no school on Monday. All right, so folks, get to work here. I think it's best if you do these questions and come see me if you have if you need help.